Hello, friend. So today I'm going to be going through problem 1.3 from Griffiths Introduction to Electrodynamics. This is still a review of some of the vectors, and we have this question where it asks us to find the angle between the body diagonals of a cube. So let's start by drawing a diagram to understand this question a little bit closer. So I'm going to quickly try and draw a cube. Okay, so I've drawn my cube, and the body diagonals here are going to be going from one corner to the opposite in the body corner. So this first one is B, we'll label it as. And the second one, if I come from this top corner, draw it all the way down to this opposite bottom corner, I'm going to label this as vector A. And the angle we're taking is the angle between vectors A and B, and this is going to be theta. So let's first write out in vector notation our vector A and vector B. So if I consider this as like a unit vector in Y, a unit vector in Z, and a unit vector in X, A from the top corner where it originally started down to this bottom corner has moved 1 in the X direction, so it has a length of 1 X hat. It's moved a positive 1 Y hat. And lastly, it is moved down, so this is going to be negative 1 in the Z hat direction. Then for our B vector, we've moved 1 in the X direction, plus 1 in the Y direction. And then this time we moved in the positive direction of Z, so we'll have plus 1 in the Z hat direction. Now I can take the magnitude of both of these just using Pythagorean theorem. So the X component squared plus the Y component squared plus the Z component squared, take the square root of that. This gives us square root of 3. In the same way, I can get the magnitude of B, which is also going to be the square root of 3. And now we're trying to find theta. And I can think of two equations that we've encountered so far that have this theta angle between two vectors. I'm going to use the dot product here because it's simple enough for us to solve for theta. Oh, this should be that the dot product is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. And we also learned in problem 1.1 that this is equivalent to A component 1 times B1 plus A2, B2 plus A3, B3. And now we've already written the vectors in this individual component form. So what I can do is just plug those values in. So I'm just plugging in the values for X, Y, and Z in this A and B. And what we find is that we have 1 plus 1 minus 1. So in total, this equals 1. And if I rewrite over here, AB cosine theta is now equal to 1. Well, we have the magnitude of A and the magnitude of B. So I get the square root 3 from A and B times each other, so square root 3 squared. Cosine theta equals 1. The square root and the square will cancel, so this is just 3 cosine theta equals 1. And finally, then I can get that cos theta is equal to 1/3, and that theta is equal to the inverse cosine of 1/3. And if you plug this into your calculator, you should get that theta is equal to 70.5 degrees. And this is our answer. Thank you for watching, and if you have any questions, please leave them in the comments below. If you'd like me to solve any specific problems, also let me know in the comments. But for today, that is all.